Hi students, in this video we're going to look at scientific notation. So after watching this video you should be able to define scientific notation, identify the number of significant figures in a number in decimal form, then express large and small numbers in scientific notation, and also convert numbers to and from scientific notation to decimal form. Right, big thing to remember with from previous lessons is our index laws. In particular, our addition law, but also our negative power law too. So 10 to the 5 is 10 times 10 times 10 times 10 times 10, 5 tens multiplied together. And if we have 10 to the negative 5, that's 1 divided by 10 to the 5. Okay. All right, scientific notation. So many numbers, especially those used in scientific and technological fields, they can be very large or very small. So for example, the speed of light is 300 million meters per second. Now, scientific notation is a way of expressing those very large and very small numbers using powers of 10. So when we've got a number here written in scientific notation, we've got this number here with that's A. We call that the mantissa. And it can be positive or it could be negative. And it's a value that is between 1 and 10. At least as a positive number, it's between 1 and 10. And then you can put a negative in front of it to make it negative. 10 is our base. And then n, that's our power or our exponent or power, and that can be anything from, it could be negative, could be positive, can be whatever we like. Now, why we use scientific notation and why we use multiplying by 10 to some power is because if we use that sort of notation, all we're doing is changing the where the decimal point is. When we multiply by 10, like 2.1 times 10 to the 2, that just means we move the decimal point 2 places to the right, and that's 210. We still have some semblance of our number written in scientific notation. The 2.1, we still see the 2 and the 1, and then the 10 times 10 to some power just actually changes where that decimal point is. So that's why scientific notation is quite useful. You get a guide for how big the number is by both the mantissa, but also the power on the 10. The bigger the power of 10, the bigger the number. The more negative the power of 10, the smaller the number. And so, so large numbers will have positive powers of 10, small numbers will have negative powers of 10, as I just said. Now, when using scientific notation, we might only use some of the values in the mantissa, and we call these digits significant figures. So the significant figures are counted from the first non-zero digit. So for example, we want to round the number 45,028,522 so that it has 4 significant figures. It works the same sort of way as rounding, except for really big numbers or for really, really small numbers. So those are the principles we're applying here. So we've got 4502, so those are our first 4 numbers. Then that 8 that comes after the 4 significant figures, that's going to make it round up. So it's 45 million, and 30,000. And that's to 4, and we just write sig figs. Now, when we're writing numbers with a certain number of sig figs, we always round the number first to the required number of sig figs and then change it to scientific notation. So if it says express the following number in scientific notation with 4 sig figs, put it into 4 sig figs first and then scientific notation. All right, so let's do some examples. Let's write the speed of light in scientific notation. So the first step is to always start off with the mantissa. So our mantissa for this one will just be 3 times 10. And basically what we're going to do for our power is count the number of digits between the first number of our mantissa and the decimal point value. And the decimal point. So the decimal point's at the end of our number here. The first digit is a 3, so we're counting the number of digits after that. 1, 2, 3, 4, 5, 6, 7, 8. So it's 3 times 10 to the power of 8 meters per second. All right, now if we're going the other way, like the size of mitochondria, we want to express this notation of 4 sig figs. So first of all, let's do our mantissa. We have 4 sig figs here, 8404. That's 7 though, we'll make it go up, or round up to 8405. The mantissa. All right, and now we need to work out our powers of 10. Now this time the digits are going to the left. So remember, if you think of your number line, left is negative, so we're going to have a negative power. And again, we're going to count the number of digits from the first digit to the decimal point value. So when we're doing positive powers, we count after the decimal point value in our mantissa. Now we're going to count everything before the decimal point value in our mantissa. So that's 1, 8, then the zeros, 2, 3, 4, 5, 6, 7, -7 meters. Now an easy way for when you're doing negative powers is just count the number of zeros in front of your number. Notice in this case we've got 1, 2, 3, 4, 5, 6, 7 zeros in front. So -7 will be my power. That's the easiest way to think about it. All right, next one, we want to express -5.63 by 10 to the 5 in decimal form. So we'll start off with -5.63. The decimal point was here, and we're multiplying by 10 to the 5. So the decimal point value will move 5 places to the right. 1, 2, 3, 4, 5. Zeros will go in all the gaps. So it's going to be -563,000 is that number in scientific notation. When we're using negative powers, once again, it's a negative power. We're just going to count 8 zeros in front of our mantissa. So 0 point, that's our first 0. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, 2, 3. And that's how we write numbers, or change numbers from scientific notation through to decimal form. Right, so after watching this video, you should be able to define scientific notation, identify the number of sig figs in a number in decimal form, express large and small numbers in scientific notation with the right number of significant figures, and then convert numbers to and from scientific notation to decimal form.